So in the last lesson, we just looked at some of these number systems. So we've natural numbers, integers, and what are called real numbers. Now, in this lesson, what I want to think about are this idea of what are called inequalities. So inequalities. So an inequality, what you can think about it as, if we think, for example, about a speed limit. So imagine on a road, there's a speed limit in which the cars on the road or trucks or whatever, they can only drive a certain speed. So they can drive, for example, 50 kilometers per hour. So what does that mean? So we could write this something like that. So we could write something like S, and we can use these symbols. So we have less than or equal to 50. So what this means is this sign, this less than or equal to 50, means that the car, for example, it can drive maximum up to 50. It can be equal to 50 or anywhere below 50. So for example, the car could go 50 kilometers per hour, it could go 40 kilometers per hour, it could go 30 kilometers per hour, 20 kilometers per hour, 10 kilometers per hour. So it can be any of these values, and it'll still satisfy this particular speed limit. So when we write something like this, where S is less than or equal to 50, this here is an example of what's called an inequality. So this is an example of an inequality. And another example is something like this. So if we take, for example, like we have looked at in algebra, we've looked at things like this. So for example, x plus 3 is equal to 7. So this here, okay, this is an example. So what we call this an equation. Okay, and it's called an equation because you have this equal signs here. So what it means is that this side, so when you take a number x and you add 3 onto it, it's equal to this side, which is equal to 7. So x is generally going to have one value. Now if we take so that's an equation. But if we compare that then to an inequality, so if we compare an equation to an inequality would look something like this. So imagine you have x plus 3, and you could have a sign in here. Instead of an equal sign, you could have, like, for example, this sign here. And this sign here means is greater than. So what we're saying is that x plus 3 is any value that's greater than 7. So let's kind of look at this a little bit more. So what's the difference between an equation and an inequality? An equation has an equal sign here. An inequality has one of these signs. Okay, so it's either going to be one of these particular signs. So you have that sign that is there. Okay, so that means is greater than. So you have that sign. You could have this sign. Okay, and that means is less than. So is less than. And a way to remember that is less than, it looks like an L. Okay, so if you remember one of them, you'll remember them all. So it looks like an L, so that means is less than. You could have something that's like this. So what that means is greater than or equal to. So is greater than or equal to. And then finally, then you can have this one. So again, this just means is less than or equal to. So is less than or equal to. So is less than or equal to. So these are the signs. So in inequalities, so they're very similar to equations, except instead of having this equal sign, you're going to have an inequality sign. And it can be any of these particular signs. So it can be is greater than, is less than, is greater than or equal to, or it's less than or equal to. Okay, so it can be like that. Now if we think about let's like solve this equation here. So what we can do is so we want to try and get x on its own here. So we want to get rid of this 3. So remember, this is x plus 3. So addition, what's the opposite of addition? Is subtraction. So to get rid of the 3 from this side, we have to minus 3. If I minus 3 from here, I have to minus 3 from this side as well. And what will happen is these two values will cancel out. And you're going to be left with just x on the left hand side is equal to, and then you're going to have 7 minus 3, so therefore x is equal to 4. So that's the value for x, so x is equal to 4. Now if we do the same thing, let's say with this inequality here, so we can solve for x. So again we do the same thing, so we have the minus 3 from this side. Okay, to get rid of the 3 we want to get x on its own, and we can minus 3 from this side, like so. So what's going to happen is, so this plus 3 minus 3 will cancel out. So you're going to be left with x is greater than, so 7 minus 3 is just going to be equal to 4. So what we can see is that the value for x is any value that's greater than 4. So if we think about, let's say we were to look on a number line, imagine this is our number line, and let's say, so we have 1, 2, 3, 4, 5. Okay, we can see that this value for x is here. So this is the value for x. So it's just 4. Okay, so it has one value. Now, if we have a look at this one here, at the inequality, this has a range of values. It's not just one value. It's any number that's greater than 4. Okay, so if we were to look at this on a number line, what does it look like? So imagine we're starting off with, so let's say you have 1, 2, 3, 4, 5, 6, 7, and this just continues on indefinitely in this direction. Okay, so what we can say is that the value for x can be any value that's greater than 4. So imagine, so what we can say is it's any value that's greater, so it can't be 4, it has to be greater than 4. So we would start here, for example, and it's all the values going in this direction. So that's what x, so these are all the values for x. So it's basically 5 and all the values that are greater than 5. And that's the difference between, so for example, an equation and an inequality. The value for an inequality can be a range of values, not just one value. Whereas with this one, okay, the value for x is just one value. X is equal to 4. Because if we take this value for 4 and put it into this equation, it'll satisfy. So 4 plus 3 is equal to 7. But for this one here, basically what we're saying is any value that's greater than 5, when you add 3 onto it, it'll be greater than 7. That's what this means, and that's what we mean by inequalities. Now what we can actually do then is we can take inequalities and we can represent them on a number line. So if we take this inequality, for example, so x, and then we have this sign here, x is greater than minus 2. Okay, so this is an inequality, and then what we can say is that the value, so x is an element. Okay, so that symbol means element when we think about sets of z. So remember, the letter z represents integers. Okay, so this letter z, it means integers. So this value for x, okay, and this value for x is going to have a range of values, not just one value. It's going to have it's going to be all the values that are greater than -2, and the values for x are going to be integers. All the values for x will be part of the set of numbers that are known as integers. And remember, integers are represented by a z. Okay, so it's capital Z, and that's just what this statement here means. It's just saying that the values for x are elements of the set of numbers called integers. That's what this means. So what we can do is we can take this and we can represent it on a number line. So imagine we have a number of values. So imagine we have a number line. So imagine this is our number line here. So we have a number line. And what we can do is we can so let's say imagine this is 0, and we have, so here on the left we have -1 and -2. Okay, and then on the right we have the positive integers. So we're going to have 1, 2, 3, 4, 5, 6, 7, and this just continues on and on in this direction. So this is just our basic number line. Now, if I want to represent, so all of the integers, for example, that satisfy this inequality, what we can do is we can represent this. So remember, the value for x is all the values that are greater than -2. So this is -2, so it has to be, it's all the values that are greater than -2. So we're going to be talking about this one here, so this one here, so this one here, this one here, this one here. So all of these ones that I'm drawing a red dot on, all of these values are represented by this inequality. So they're all the values that are greater than -2. So basically we're representing all of these guys here. So again, it's going to be all of these the whole way right up. Okay, and that will continue on indefinitely. So this inequality can have, so the value for x can have a range of values. And all of these values that are greater than -1 will satisfy this inequality. So for example, if I was to put in -1 in here, so -1 is bigger than -2. If I was to put in 0 in there, so again 0 is greater than -2. If I was to put 1 in there, 1 is greater than -2, and so on and so forth, and that just continues on indefinitely in this direction. This example of an inequality, so the inequality is x, and we can just do it in red, so x is less than or equal to 3. And what we're saying is that x is an element of or, and remember this letter or represents what are called real numbers. So real numbers. So what would that look like? Like what kind of values could x have? So again, let's have a look and draw our number line, and we can place these on the number line. So we'll draw a number line, something like this. And we can, so let's say if we start off here, so this is 0, and then we have 1, 2, 3, 4, 5, 6. Okay, so we're just selecting a couple of numbers. So what we're saying is that the value for x is less than or equal to 3. So what numbers are going to be included in that? So you're going to be including, so 3 is going to be included, so it can be equal to 3. 2 will be included, 1 will be included, 0 will be included, and then it just continues on in this direction indefinitely. So -1, -2, -3, and it goes on and on and on. So what we can say then is that all of these numbers here will satisfy, all of these numbers 3 and below will satisfy this inequality. So for example, 3, if I replace x with 3, with the value from 3, so 3 is equal to 3. Okay, if I put in the value for 2, where x is equal to 2, then 2 will be less than 3. Okay, so that satisfies it. If I put in the value for 1, 1 is going to be less than 3. If I put in the value 0, 0 is less than 3. So again, all of these numbers here, they all satisfy this inequality here. And remember, x is a real number. These are just two of the ways that, these are inequalities, and they're just two ways that we can, just some of the ways that we can actually represent inequalities on a number line. Okay, so just to recap, we've talked about inequalities. So an example of an inequality is, for example, a speed limit. So if the speed limit is 50, for example, and we can write the inequality like this. So S, which represents the speed limit, is less than or equal to 50. So again, this is an example of an inequality. So what does that mean? That the speed can be anywhere from 50 below. So it could be 50 kilometers per hour, 40 kilometers per hour, 30 kilometers per hour, 20 kilometers per hour, 10 kilometers per hour. Now, if we have a look at this here, so we have an equation. So x plus 3 is equal to 7 is an example of an equation. Okay, an example of an inequality, they look very similar to equations, but there's one slight difference. So inequalities, so x plus 3 is greater than 7. That's an example of an inequality. And instead of having an equal sign, you have this inequality sign. So that the inequality sign that's put in here in inequalities, it can be any of these ones. So you can have, so this one, which means greater than, is less than, is greater than or equal to, is less than or equal to. And a way to just remember these inequalities is, if you remember one, for example, like this looks like a squashed L. L represents less than. So if you remember this one, you'll be able to remember all the rest of them. So these ones, so this for example is just less than, and then you have this sign underneath which just means less than or equal to. So if we look at these two, so let's say like with an equation, like the value for x has just one value. So in this case x is equal to 4, so we can solve for x. If we think about an inequality, like the value for x is going to have a range of values. So in this case it has, so for this one, x is greater than 4, so it can be all of the numbers greater than 4 or above 4. It can be the values for x. So inequalities then can be represented on the number line. So for example, this here is an inequality, so x is greater than minus 2. And this here is just a clause or a statement that tells you more about the values for x. So all this tells us is that x is an element of z, so that means that the values for x are all going to be what are called integers. So if I was to represent this on the number line, it would look something like this. So basically you have your number line, and then these red dots represent some of the values that x could be. So for example, in this case where x is greater than minus 1 or minus 2, so here's minus 2, and x is greater than minus 2. So x can be minus 1, 0, 1, 2, 3, 4, 5, 6, 7. So these are the values for x. It can be any of these values. Similarly here, so for example, this is our inequality. X is less than or equal to 3, and x is an element of, is a real number. So it's an element of R, which represents real numbers. So again, in this case, so x is less than or equal to 3. So the values for x can be 3, for example, or any number that's less than 3 on the number line. They'll satisfy this inequality. So again, that's just inequalities and representing inequalities on the number line.